Today we will learn how to solve homogeneous and non-homogeneous second-order linear differential equations. The standard form of second-order linear differential equation is a d square y upon dx square plus b dy by dx plus cy is equals to any function of x. Or we can write this in auxiliary form, a d square plus bd plus c is equals to any function of x, where a, b and c are constants and y is the sum of complementary function or particular integral, or in short, y is the sum of CF plus PI. But what is CF plus PI? Complementary function is a solution to a d square plus b d plus c equals to 0, and particular integral is a solution of a d square plus bd plus c is equals to any function of x. The only difference is on the right hand side of both equations. The complementary function is always equals to 0 and particular integral is always equals to some function of x. Let's see steps for solving second order linear differential equation. First, you need to find the roots of the equation. Either you can find it by quadratic equation, or you can also find it by middle term break. Then we need to find the complementary function by putting the roots in the equation. Complementary function is equals to c1, where c1 is any constant, times integral of lambda 1. Lambda 1 is the root of the equation we have already found in the previous step, lambda 1, plus c2 integrals times lambda 2. Then we need to find the particular integral by using the formula particular integral plus 1 upon auxiliary equation times the function of x. Then we can find the y by putting the complementary function and particular integral in the equation y is equals to cf plus pi. But today we are going to solve a case in which the function of x is any quadratic equation. So for that, steps are almost same with a slight difference. You also have to find the roots of the equation, then you have to find the complementary function by the same formula, then you need to find the particular integral by the same formula. But now here comes the different part. You need to take out the lowest degree from the term f of d to make the first term 1, so that we can use the binomial theorem for a negative index, so that the equation becomes 1 plus phi d or 1 minus phi d. Now we need to take the function of d in the numerator so the whole power becomes minus 1, and then apply binomial theorem and solve for particular integral. Then, as usual, you can find the y by putting the cf and pi in the equation y is equals to cf plus pi. Let's see an example. Here I have an equation d square y by dx square plus 2dy by dx minus 3y is equals to 5x square. The first step we need to do is to transform the above equation in the auxiliary equation, which is d square plus 2d minus 3 equals to 0. We need to find the roots of the equation. We can either use middle term break or quadratic formula. Now we can find the complementary function by putting the roots in our equation over here. So our equation becomes c1 times e to the power x plus c2 times e to the power negative 3x. Now we need to find our pi. So for that, we need to know fd and function of x. Function of x, as you know, is here the 5x square, and fd is the auxiliary equation we have already made before, which is d square plus 2d minus 3 equals to 0. Now let's put function of d and function of x in our equation of pi. We get 1 over d square plus 2d minus 3 times 5x square. Now we need to take the lowest degree term from the function of d, which is d square plus 2d minus 3, to make the first term 1. Here we have the lowest degree term, which is minus 3, so we need to divide the whole equation by negative 3. Our equation becomes, after simplifying, negative 1 over 3 times 1 minus d square over 3 plus 2d over 3 times negative 1 whole power times 5x square. Now we need to apply binomial theorem. Binomial theorem for 1 minus x whole square minus 1 is equals to 1 plus x square plus x cube plus x4 plus x5 plus x6 and so on till the infinity. So we open out this term by applying binomial theorem, and we get the equation negative 1 over 3 times 1 plus d square over 3 plus 2d over 3 plus d square over 3 plus 2d over 3 whole power square plus d square over 3 plus 2d over 3 whole power cube, and so on. So after opening, our equation for pi becomes negative 1 over 3 times 1 plus d square over 3 plus 2d over 3 plus the formula of a square plus 2ab plus b square, which we get over here d4 over 9 plus 4d square over 9 plus 4d cube over 9. Then we need to expand the formula of cube, which is a cube plus b cube plus 3a square b plus 3b square. So after opening, it becomes d power 6 by 27 plus 8d cube over 27 plus 6d5 over 27 plus 12d cube over 27, and so on till times 5x square. Since our function here is 5x squared, it means if we differentiate more than twice, the whole term will become 0. So we are going to cancel out all the derivatives which has power greater than 2. This means we got this cancel, 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 and cancel. So the equation remains negative 1 over 3 times 1 plus d square over 3 plus 2d over 3 plus 4d square over 9 times 5x square. After multiplying the 5x square with each term, we get 5x square plus twice the derivative of 5x square over 3 plus 2 into derivative of 5x square over 3 plus 4 times twice the derivative of 5x square over 9. So after taking the derivative, our equation becomes negative 1 over 3 times 5x square plus 10 over 3 plus 20x over 3 plus 40 over 9. After more simplifying it, we get negative 5x square over 3 minus 20x over 9 minus 10 over 27. Now we need to put the pi and cf in our equation for y, which we have over here y is equals to cf plus pi. Putting the values of pi and cf in our equation. So our equation for y becomes c1 times e power x plus c2 times e power negative 3x minus 5x square over 3 minus 20x over 9 minus 10 over 27. Now this whole equation is y, and now our answer here is finished. Thank you.